Hello, Mr. Kovac here again, working on more factoring for all my fans of factoring out there. We're factoring quadratics. This time it's going to be a trinomial, and we're going to use what we call the AC method. All right, the AC method comes from the idea that all quadratics have a general polynomial characteristic, ax squared plus bx plus c. All right, so we use these different coefficients to help us to factor this polynomial. All right. So we start off, we look, as always, first rule of factoring is, do we have a GCF? I see k squared minus 2k minus 35. There is no GCF. So then I begin our AC method. And I start this with a t-table, or make a simple chart. And in the upper left corner, it's called the AC method because we put in that upper left corner a times c. And in the upper right corner goes our b. So I look at my polynomial here, and I've got a 1 for a and a negative 35 for c, so it's 1 times negative 35, which is negative 35. And for my b is negative 2, so that's going to go on the other side here. So this is the first step in the AC method. The next thing we do is we ask ourselves, what two numbers multiply to give us negative 35, but when we add them, we get negative 2. All right, so I start out by listing my factors of 35. 1 times 35. 2 is not going to work. 3 is not going to work. 4 is not going to work. 5 and 7. All right, so these are the set of factors for 35. Now I look at this, I can see that it's negative 35, so that means one of my factors has to be negative so that the product is negative. It gets us negative 35. While at the same time, we want it to add up to negative 2, so that means the larger of our two factors needs to be negative as well. So one of the factors needs to be negative, and it's actually the larger one that needs to be negative. So 1 and negative 35, that multiplies to give us negative 35, but adds up to negative 34, which is no good. That's not what we're trying to do. So that's not going to happen. We next look at 5 and 7. Again, 5 times negative 7 is negative 35, and when we add them together, we get negative 2. So this is our wonderful pair, all right, our factoring friends. So we go ahead and start our method. Once we have them, we're going to rewrite our equation. K squared is going to stay. Now we're going to use our two factors, 5 and negative 7. We're going to use them to create two terms out of that negative 2k. So instead of negative 2k, we're going to split it up as plus 5k minus 7k. And then the minus 35 comes down. And our AC method is well underway. So what we do next then is we are going to use the grouping. So we group the first two, we group the second two. And as you may recall, the grouping method starts off by the first parenthesis, you take a GCF out, which is k, and we're left with k plus 5. We go to the second parenthesis, we look for the GCF. I can see we've got 7 and 35 there. So I'm going to take a 7 out. Now because the first term there, negative 7k is negative, I'm going to factor out a negative 7. This is very important when we're doing our AC method. We have to factor the negative out so that we're going to have negative 7k divided by negative 7 gives us a positive k. Negative 35 divided by negative 35, but divided by negative 7 is going to give us positive 5. And that is the critical piece right there. We have to make sure we get that k plus 5 again, but to make the whole grouping thing work. So then we look, we've got k plus 5 in both cases, so that k plus 5 factors out. And then we start our second parenthesis, the first parenthesis times the second parenthesis, which is k minus 7, because that is what is left over. And we have now just successfully applied the AC method to this particular polynomial. All right. So that's one example. Let's try another example here. Another example might be 5x squared minus 13x plus 60. Now this one's going to be a little more challenging, but we first start off, as always, looking for the GCF. So we're going to go ahead and look. There is no GCF available. 5, 13, and 6, nothing common to factor out of those three coefficients. there's not an x in each term, so we're going to go ahead and begin our AC method. Again, we start with a wonderful t-chart. And again, in the upper left, it's a times c. In this case, 5 times 6, which is 30. And we want that to add up to negative 13, because that's our b. There we are, b. So what factors of 30 will add up to negative 13? So I start out, I'm not sure. I'm going to list out all my factors of 30. 1 and 30, 2 times 15, 3 times 10. Boy, there are a lot of factors here. 4 is not going to work. 5 and 6. So maybe it's not as bad as I thought it was. There are 4 pairs of factors. Now I'm going to look, and I see I have to get it to equal negative 13. So my AC, my product, has to be positive 30, while the sum is negative 13. That tells me I'm going to need to have both of my pieces be negative, both of my factors be negative. So I look at it, negative 1, negative 30. Negative 1 plus negative 30, that's not going to work, right? That's going to be negative 31. Negative 2, negative 15. Again, multiply and get positive 30. Add them, you're going to get negative 17. Well, that's not going to help us out because we want negative 13. I go ahead and look, negative 3, negative 10, negative 13. There it is. Ding, ding, ding. There is our winner. This is the pair we want. This is what we're looking for. So we take those two, and we're going to split up our linear term from the quadratic. So we start off 5x squared. Now it was minus 13x. We are going to split that up again. We're going to split it up as negative 3x and negative 10x, or minus 10x, plus 6. So we have that completed. Now we go ahead. We've got 4 terms. We are going to group them up. Group up the first two. GCF, that's just going to be x, leaving us with 5x minus 3. Go to the second one. I can see between 10 and 6, I'm going to have a GCF of 2. Now it's a negative 10 out front, so I'm going to take a negative 2 out. I'm going to factor that out, and that's going to leave us with a positive 5x minus 3, which is fantastic. Once again, you have that negative coefficient at the beginning there, that leading term. You want to try to factor that negative out. It really is a must for the GCF. So now we go ahead and we look, 5x minus 3 in the first one, 5x minus 3 in the second one. So we can go ahead and factor that out, 5x minus 3. It is common. It is a common factor between these two megaterms, if you will, jumbo terms. So then we factor those out and we'll write what's left. So that's going to be 5x minus 3 times x minus 2. And that's how we complete the AC method. 2 fantastic examples of it. Enjoy.